Hi, I wanted to give a brief walkthrough of how to load data into SPSS and do the simple t-tests as we did in class on Monday. So I've downloaded this file, tolsummary.csv, and I put it on my desktop. You might not have it on your desktop, but you should know where it is. If you downloaded it, it might appear in your downloads folder, so move it to somewhere where you can access it later. And then start SPSS. This takes a few seconds to load, so it loads through this menu item, IBM SPSS statistics, but eventually, maybe a minute after you start it on these computers, you'll see two windows, and there'll be an open existing data source, or open another type of file. Just ignore this one, hit cancel, because we're going to open up the data through a different means. I'd opened up, I guess, two versions of this. So once you have a single window open, that'll look like an empty data file. Then go to File, Read Text Data. This is what you do if you have a CSV data type. And it'll open up a dialog here. So search for, and this will look for things in a text format like TXT or DAT or CSV. And mine is going to be on the desktop. So I'm going to go to desktop, and here is the file, tol-summary.csv, and I'll hit OK. It then gives me this text import wizard, and generally, you can just go to the next slide. We want to load this as a delimited file because it's comma separated. That's what CSV stands for. And our variable names included at the top of your file. In this case, they are, so we would put yes. And then I think everything on here, the default is fine. And now it actually separates them based on comma. If you used a different separator, you could select that here, and it'll have the columns labeled properly. And now, because one of my columns didn't have a label, it says invalid variable names in this application. For this application, have been found and changed, and it's just going to call it V1. We can call it whatever we want because this is just a line number. And we could then go through and check each of these to make sure it was entered in the right format, but by default it should be pretty good at doing that. And then we just hit finish, and it will bring up a new window that has our data set in it. So this data has, let's look at this, it's got 39 lines. That each line represents one condition of one subject, and each subject has 3 lines. So the conditions are size 3, size 4, and size 5. Now some people did a mouse condition, and some people did a touchpad condition, and so condition and size represent our two major independent variables here. We have a subject code here. We have a measure of how many steps it took to complete each puzzle, which is here. This variable turns out not to be important in this version of the task. It's always 1. The score is always dictated by the size of the problem, and so everyone's is going to be the same for equal size problems, so that's not going to be interesting. But then there's the trial time. The trial time is the average time it took to complete puzzles of that size for that person in milliseconds. So 5267 represents 5.2 seconds to complete puzzles of size 3. So our task is to do comparisons of means of different groups, and what we want to do is compare both for the dependent measures of step and trial time. We want to compare M's versus T's, and then 3's versus 4's, and 4's versus 5's, and 3 versus 5's. So let's go to the Analyze. Under the Compare Means, there's going to be an independent samples t-test. which is going to be appropriate for the M versus T, at least. And we're going to use it for the different problem sizes, although we could also use a paired samples t-test for that if we had our data in a different format. So it brings up this dialog, and it will let you do the test simultaneously on multiple dependent measures. And so we're going to put the dependent measures we care about, step and trial time, here. There's nothing about the procedure that this just makes it easier to do these. It doesn't change the results at all. We could do them one at a time or all at once, and you get the same results. It just makes it sort of simpler. And then we have to pick the independent variable. And the two independent variables we cared about were condition, which would be M versus T, and size, which would be 3 versus 4, or 4 versus 5, or 3 versus 5. And so let's, and you're going to have to do both of these for the assignment. So let's pick size just because it's a little more difficult. Well, I don't want to put it as a test variable or a dependent measure. I want to put it as a grouping variable. But now it gives me these two question marks because it's not smart enough to know that there's two conditions that I want to compare, but I need to compare just two of them. So I have to define groups, and I have to specify the values that I want to compare. So I'm going to put 3 here and 4 here, and then hit continue. There's really no other options to give, and so I'm going to hit OK. And here it gives the results. First, it will give some basic statistics like the mean, the standard deviation, the standard error, the count of each group. But at the bottom, it gives the results from the statistical test. The first two columns refer to a test of Levene's test for equality of variances. It turns out that the t-test requires the variance of your two groups to be the same, and if they're not, then some of the assumptions could be violated. So it actually provides a test for whether they are. So this is the f value of that test, and that's just a statistic that it computes. And if this is significant, which means if this is the p-value, if this p-value is very small, less than 0.05, then you would conclude that the variances differ between the two groups. And if they differ, then you definitely shouldn't be using this first row where you assume they're the same, and you should be using the second row where you assume they're different. You see that we have the two tests, one for the dependent measure of step and one for the dependent measure of trial time. So let's just look at step for now. And what you'll notice is that the t-values for these are the same, but the degrees of freedom slightly change. And especially because this was not significant, these tests are going to be almost the same. I'd recommend that you always just report the version for equal variance is not assumed, because if they are identical, they're going to be if they are identical, you're going to get basically the same number, and you should get basically the same numbers for them anyway. So it's just safer to report this second one. And here we see that the t-value is -5.6, the degrees of freedom is 20, and the significance is 0.000, which means that's smaller than the computer can represent, and it's a value less than 0.05. So this would be a significant difference. Now there's a couple things you can do. You can select one of these and right-click and say copy, and then take it over into Microsoft Word and hit paste. And that table will appear. But for this assignment, I want you to practice writing what this result means. So for the step, it would say, you'd say something like an independent samples t-test, and this is a two-tailed t-test, independent samples, two-tailed t-test, showed that there was a significant difference between, now my independent measures here are, if I go back, it's going to be problems of size 3 and problems of size 4. Problems of size 3 and 4 on, and then the dependent measure is the number of moves required to complete the puzzle. And then in parentheses I would report what the statistics are. And here I would say T and give the number of degrees of freedom on 20.6 is equal to negative 5.6. P is less than 0.001. That's all we know. We know it's, if for the second one you could say P is equal to 0.019, but because this is smaller than we can measure, you would just say it's less than 0.001. That's how you would report that particular test. All right,